Hello, everyone, and welcome to this practical session on Explainable AI. In this session, you are going to get hands-on experience with some of the most widely used XAI methods in machine learning. The goal is not only to understand how these methods work conceptually, but also to see how they can be applied in practice using Python. We will work with two datasets throughout this session. The first one is the diabetes dataset, introduced by Efron and colleagues in 2004. It contains 10 clinical variables, including age, sex, body mass index, average blood pressure, and 6 blood serum measurements, collected from 442 diabetes patients. The target variable is a quantitative measure of disease progression 1 year after the baseline. This dataset will be used for tabular regression tasks. The second dataset is a subset of ImageNet, specifically the ImageNet 50 sample provided through the SHAP library. It contains natural images covering a wide range of object categories, and it will be used to explore XAI methods applied to image classification with a pre-trained deep learning model. Now, let me walk you through the XAI methods we are going to practice. We start with intrinsic interpretability. The decision tree model is a naturally interpretable model, and we will visualize it graphically and extract the decision rules that apply to individual instances. Next, we move into feature importance methods. We will compute the Gini importance, which quantifies how much each feature reduces impurity across all decision tree splits. We will also compute permutation feature importance, a model-agnostic method that measures the drop in model performance when a single feature is randomly shuffled. We will apply this to both the decision tree and the random forest. After that, we will explore partial dependence plots, or PDPs. These plots show the marginal relationship between a feature and the model's prediction, helping us understand how a feature influences the outcome on average across the dataset. Then we will spend a significant portion of the session on SHAP, Shapley additive explanations. SHAP is grounded in game theory and assigns each feature a contribution value for a specific prediction. We will generate force plots for individual predictions and summary plots to visualize feature importance across the full dataset. We will apply SHAP to the tabular models first, and then to a pre-trained ResNet 50 convolutional neural network classifying images from ImageNet. Finally, we will implement GradCam, gradient-weighted class activation mapping. This method uses the gradients flowing into the last convolutional layer of a neural network to produce a heat map highlighting the image regions that were most influential for a given prediction. To run this notebook, you will need several Python libraries installed in your environment. Please make sure the following are available before the session starts. From scikit-learn, you will need the ensemble, tree, model selection, datasets, and inspection modules. These cover the diabetes dataset, decision tree, random forest, permutation importance, and PDPs. You will also need pandas and NumPy for data handling, and matplotlib and seaborn for visualization. For the SHAP-based exercises, you need the SHAP library. For the image-based exercises, you need TensorFlow with the Keras Applications module, which provides the pre-trained ResNet 50 model. That covers everything you need to know to get started. Make sure your environment is set up, download the notebook, and you are ready to go. Good luck and enjoy the session.